Okay, picking back up with page 2, we'll do a few problems right here. Taking a look at a little bit of review. On the quiz, we're not going to have derivatives of inverse trig functions just yet. However, a little bit of a reminder, if we took the derivative of inverse sine, hopefully you do remember that's going to be 1 over the square root of 1 minus u squared. Then we'll have our du dx. So as we're looking at number 4, we've got the natural log. As we find dy dx here, hopefully you remember that the natural log, as we're taking that derivative, we're going to go 1 over whatever is inside of the natural log, 1 over that argument. Now I have to use the chain rule. I'm going to take the derivative of this inside portion. That's what we just took a look at up above. So we're going to say this is 1 over the square root of 1 minus, well, whatever's inside of inverse sine. In this case, it's a 2x. That's your u. You're going to have that squared. Then we'll have our du dx. The derivative of our 2x is just going to be a 2. So as we clean this up, we'll have dy dx is going to equal, well, we can bring our 2 up here. We'll have inverse sine of 2x. And then cleaning up this radical down below, that would be 1 minus a 4x squared. So that's going to be number 4. As we take a look at number 5, a couple of things to remind you about with number 5. First of all, if we were taking a derivative of inverse tangent, you might remember from our notes, as we do that, let me just put a dx right there. You're going to get 1 over 1 plus u squared, and then a du dx with the chain rule. Likewise, if I took a derivative of 3 to the u, that's going to be 3 to the u times the natural log of 3. So taking a look at number 5, we'll have our dy dx. Of course, we've got 3 raised up to a power, so we're going to apply this right here, the derivative of 3 to a function up there. We'll get 3 to the inverse tangent of x times the natural log of 3. But now we're going to have to finish this up. I didn't write this out here. You got to have your du dx. Forgot to jot that down. Got to take that derivative of the inside part. What's the derivative of inverse tangent? Plain and simply, it's 1 over 1 plus x squared. So cleaning this up, we can do that very quickly. We'll have 3 to the inverse tangent of x multiplied to the natural log of 3 all over 1 plus x squared. And that would be number 5. Taking a look at number 6, we're going to need our change of base formula. This is log base 10. So this is really the natural log of the sine of x all over the natural log of 10. We need to do this because we need to get natural log into the picture to be able to take our derivative. That natural log of 10 is a constant, so I'll take that 1 over natural log of 10, bring it out in front. Dy dx, well, we've got our constant of 1 over the natural log of 10 right here. But the derivative of ln of sine of x, 1 over whatever is inside of that, that's 1 over sine of x. Chain rule, the derivative of sine is cosine of x. But tell you what, cosine over sine is really cotangent. So to clean this up, to write it in the most simple way, we could say, well, this is the cotangent of x. And then we've got our natural log of 10 down below. So that would wrap up problem number 6.